All right, find a comfortable spot and let your mind settle. Tonight, we're not going to worry about the busy details of our world. Instead, we're going to take a slow, lazy trip through our cosmic neighborhood, our home base in the universe, the solar system. There's no test at the end, no need to memorize anything. The goal here is just to float along and marvel at some of the beautiful, strange, and sometimes downright silly things that share this little corner of the galaxy with us. We'll treat it like a long, quiet road trip, starting from the very center and working our way out to the mysterious, frosty edges. So, for any tour of the solar system, you have to start at the head office, the main event, the undisputed landlord of the entire neighborhood, our star, the Sun. It's impossible to overstate just how dominant the Sun is. Here's a wild thought to kick us off. The Sun contains 99.86% of all the mass in the entire solar system. That means everything else, all the planets, including giants like Jupiter, all the moons, all the asteroids and comets, every rock and every speck of dust, all of it combined makes up just a tiny 0.14% fraction. It's a rounding error. We are all just living in the Sun's leftover cosmic dust. Because of this immense mass, its gravity is the glue that holds our whole family of planets together. Everything we're about to visit is just dancing to the tune of the Sun's gravitational pull, locked in orbit around it. And what is this colossal ball of stuff made of? It's not rock or fire in the way we think of it. The Sun is overwhelmingly made of just two simple elements, about 74% hydrogen and 24% helium. But it's so hot, these elements don't exist as normal gas, they exist as a plasma, a superheated state of matter, where electrons are stripped away from their atoms. It's a seething, swirling ball of charged particles, a chaotic and beautiful storm of cosmic proportions. At the very heart of this giant ball of plasma is the Sun's core. This is the engine room, and the conditions here are almost impossible to imagine. The pressure is about 265 billion times the atmospheric pressure here on Earth, and the temperature is a staggering 15 million degrees Celsius. It's in this incredible cosmic furnace that the Sun's magic trick happens: nuclear fusion. Under this immense pressure and heat, the Sun fuses hydrogen atoms together to create helium. Each time it does this, a tiny amount of mass is converted directly into a huge amount of energy, according to Einstein's famous equation, E equals mc squared. This is the energy that has powered our solar system for 4.5 billion years. This energy, in the form of light particles called photons, then begins a very long journey to get out of the Sun. A photon isn't just zipping straight from the core to the surface. It gets absorbed and re-emitted countless times by the dense plasma, taking a random walk outwards that can last for tens of thousands or even hundreds of thousands of years. So the light that finally emerges from the surface is ancient. But once it's out, it's a straight shot through space. And here's a fact that connects us directly to our star. It takes that sunlight an average of 8 minutes and 20 seconds to travel the 150 million kilometers to Earth. This means if the Sun were to magically vanish right now, we wouldn't know about it for over 8 minutes. The sunlight hitting your face on a sunny day is in a way a message from the past. The sun also doesn't spin like a solid ball. Because it's a plasma, it has what's called differential rotation. Its equator spins much faster than its poles. The poles complete a rotation in about 25 Earth days, while the poles can take up to 35 days. This twisting motion tangles up the sun's powerful magnetic field lines, leading to all sorts of interesting activity on its surface. These tangled magnetic fields can store up huge amounts of energy, which can then be suddenly released in what we call a solar flare. A solar flare is an intense, brilliant burst of radiation, a flash of light that can release the energy of millions of hydrogen bombs at once. If a powerful flare is aimed at Earth, it can disrupt our radio communications and navigation systems. Sometimes these events are even bigger. They can cause a coronal mass ejection, or CME, where a giant cloud of magnetized plasma, billions of tons of it, is burped out from the sun and travels through the solar system. If a CME hits Earth, it can interact with our magnetic field to create beautiful auroras, the northern and southern lights, but it can also be dangerous, potentially damaging power grids and satellites. The sun isn't just a gentle, constant source of light. It has a dynamic and sometimes stormy personality. But our star won't be like this forever. It's about halfway through its 10 billion year main sequence lifespan. What happens when it runs out of hydrogen in its core? Well, it will begin to fuse helium and other elements, and its structure will change dramatically. In about 5 billion years, the sun will swell up into a red giant, becoming hundreds of times larger than it is today. It will be so big it will swallow Mercury, Venus, and almost certainly Earth. Our planet will be vaporized within the outer layers of our dying star. It's a dramatic end, but thankfully a very, very long way off. After this phase, the sun will puff off its outer layers, creating a beautiful planetary nebula, and the core that's left behind will collapse into a new, strange kind of object. The sun will end its life as a white dwarf, a hot, incredibly dense, Earth-sized remnant that will slowly cool and fade over trillions of years. With that rather dramatic future in mind, let's leave the sun behind us and begin our journey outwards to the first stop on our tour.
Our first port of call is the smallest and innermost planet, Mercury. This little world is a planet of extremes. If the sun is the giant landlord, Mercury is the tenant living right next to the furnace. To begin, Mercury is the smallest planet in the solar system, only slightly larger than our own moon. It's a dense little ball of rock and metal, and it lives its life in the fast lane. Being the closest planet to the sun, it has the fastest orbit. Mercury zips around the sun in just 88 Earth days. So, if you lived on Mercury, you'd have a birthday every 3 months. But while its year is super short, its day is bizarrely long. Mercury is tidally locked to the sun, but in a strange way. It's not a perfect one-to-one lock like our moon is to Earth. Instead, it has what's called a 3-to-2 spin-orbit resonance. This means it rotates on its axis exactly 3 times for every 2 orbits it completes around the sun. The result of this weird dance is that a single solar day on Mercury, the time from one sunrise to the next, is about 176 Earth days long. That's exactly 2 of its years. You'd have to wait 2 full Mercurian years to see the sun rise again. This combination of being close to the Sun and having a super long day leads to another of its extremes. Mercury has the most dramatic temperature swings in the solar system. During its long day, with the Sun beating down relentlessly, the surface temperature can soar to a blistering 430 degrees Celsius, hot enough to melt lead. But during the equally long night, with no real atmosphere to trap the heat, the temperature plummets to a shockingly cold -180 degrees Celsius. It's a world of incredible fire and ice. Speaking of ice, here's one of Mercury's biggest surprises. For a planet so scorched by the Sun, you'd never expect to find water. But scientists were stunned to discover that Mercury has deposits of water ice hiding in permanently shadowed craters at its poles. These craters are deep enough that their floors never ever see sunlight, allowing ice to remain frozen for billions of years in the bitter cold. Another of Mercury's secrets is what's on the inside. While it's a tiny planet, it's incredibly dense. The reason for this is that Mercury has a massive iron core, which takes up about 85% of the planet's radius. For comparison, Earth's core is only about 55% of its radius. Mercury is, in essence, a giant ball of metal with a thin, rocky crust. Scientists aren't sure why its core is so disproportionately large. One theory is that a giant impact early in its history blasted away much of its original rocky mantle, leaving just the dense core behind. This giant, partially molten core also gives Mercury another surprising feature: a magnetic field. It's very weak, only about 1% as strong as Earth's, but the fact that it has one at all is strange for such a small, slowly rotating planet. Mercury's weak but complex magnetic field is another puzzle that scientists are still trying to piece together. As you look at pictures of Mercury's surface, you'll see it's covered in craters, much like our Moon. But you'll also see another prominent feature: long, winding cliffs or scarps that can stretch for hundreds of kilometers. These are a clue to the planet's history. These scarps, or lobate scarps as they're called, are believed to have formed as the planet's giant iron core cooled and contracted over billions of years, causing the crust to wrinkle and crack like a drying apple. Mercury is literally a shrinking planet. All right, our time at this little world of extremes is up. Let's fire up our imaginary thrusters and head to the next planet out, a world that's often called Earth's twin, but as we'll see, it's more like our evil twin. We're headed for Venus. Venus is the second planet from the Sun, and in many ways, it's very similar to Earth. It's roughly the same size, has a similar mass, and is made of similar rocky material. For a long time, people imagined it might be a lush, tropical paradise hidden beneath its thick clouds. Oh, how wrong they were. Venus is perhaps the most hellish, inhospitable place in the entire solar system. Its main claim to fame, and the source of its misery, is its atmosphere. It is thick, choking, and incredibly dense. While Earth's atmosphere is mostly nitrogen and oxygen, the atmosphere of Venus is about 96% carbon dioxide, a potent greenhouse gas. This has led to a runaway greenhouse effect. Sunlight comes in and heats the planet, but the thick CO2 blanket doesn't let the heat escape. The result: Venus is the hottest planet in the solar system, even hotter than Mercury, which is much closer to the Sun. The average surface temperature is a steady, horrifying 465 degrees Celsius, hot enough to melt lead. But during the equally long night, with no real atmosphere to trap the heat,
the temperature plummets to a shockingly cold -180 degrees Celsius. It's a world of incredible fire and ice. Speaking of ice, here's one of Venus's biggest surprises. For a planet so scorched by the sun, you'd never expect to find water. But scientists were stunned to discover that Venus has deposits of water ice hiding in permanently shadowed craters at its poles. These craters are deep enough that their floors never ever see sunlight, allowing ice to remain frozen for billions of years in the bitter cold. Another of Venus's secrets is what's on the inside. While it's a tiny planet, it's incredibly dense. The reason for this is that Venus has a massive iron core, which takes up about 85% of the planet's radius. For comparison, Earth's core is only about 55% of its radius. Mercury is, in essence, a giant ball of metal with a thin, rocky crust. Scientists aren't sure why its core is so disproportionately large. One theory is that a giant impact early in its history blasted away much of its original rocky mantle, leaving just the dense core behind. This giant, partially molten core also gives Mercury another surprising feature: a magnetic field. It's very weak, only about 1% as strong as Earth's, but the fact that it has one at all is strange for such a small, slowly rotating planet. Mercury's weak but complex magnetic field is another puzzle that scientists are still trying to piece together. As you look at pictures of Mercury's surface, you'll see it's covered in craters, much like our Moon. But you'll also see another prominent feature: long, winding cliffs or scarps that can stretch for hundreds of kilometers. These are a clue to the planet's history. These scarps, or lobate scarps as they're called, are believed to have formed as the planet's giant iron core cooled and contracted over billions of years, causing the crust to wrinkle and crack like a drying apple. Mercury is literally a shrinking planet. All right, our time at this little world of extremes is up. Let's fire up our imaginary thrusters and head to the next planet out, a world that's often called Earth's twin, but as we'll see, it's more like our evil twin. We're headed for Venus. Venus is the second planet from the Sun, and in many ways, it's very similar to Earth. It's roughly the same size, has a similar mass, and is made of similar rocky material. For a long time, people imagined it might be a lush, tropical paradise hidden beneath its thick clouds. Oh, how wrong they were. Venus is perhaps the most hellish, inhospitable place in the entire solar system. Its main claim to fame, and the source of its misery, is its atmosphere. It is thick, choking, and incredibly dense. While Earth's atmosphere is mostly nitrogen and oxygen, the atmosphere of Venus is about 96% carbon dioxide, a potent greenhouse gas. This has led to a runaway greenhouse effect. Sunlight comes in and heats the planet, but the thick CO2 blanket doesn't let the heat escape. The result? Venus is the hottest planet in the solar system, even hotter than Mercury, which is much closer to the Sun. The average surface temperature is a steady, horrifying 465 degrees Celsius, hot enough to melt.
Why does Venus spin backwards? No one is entirely sure. One leading theory is that it was struck by a massive asteroid early in its history, which literally knocked it upside down, or at least tilted it so far that it effectively reversed its spin. Another idea is that the thick, heavy atmosphere has, over billions of years, created enough friction with the solid planet to slow its rotation to a stop and then reverse it. It's another great Venusian mystery. Because of its thick cloud cover, we can't see the surface of Venus with regular cameras. To map it, scientists have had to use radar, which can pierce the clouds. These radar maps have revealed a world covered in volcanoes. Venus has more volcanoes than any other planet in the solar system, with over 1,600 major volcanic features identified. Most of these are thought to be long dormant, but some recent evidence suggests that there might still be active volcanism on Venus today, with fresh lava flows detected by orbiting spacecraft. It's a geologically fascinating, if terrifying, world. Despite being named after the Roman goddess of love and beauty, Venus is not a welcoming place. All right, let's leave this planetary pressure cooker behind and head for the third rock from the Sun, a planet that should be much more familiar. It's a pale blue dot, a haven of life in the vastness of space. It's our home. We're heading for Earth. From a distance, the first thing that makes Earth special is obvious: the water. Earth is the only known planet in the universe where water can exist in a stable liquid form on its surface. This is thanks to our planet's perfect distance from the Sun in a region called the habitable zone, or sometimes the Goldilocks zone. Not too hot, not too cold, but just right. This abundance of liquid water is the key ingredient that allowed life to arise and flourish here. Another critical feature that makes Earth a haven for life is something you can't see: its magnetic field. Deep in our planet's core, churning liquid iron acts like a giant dynamo, generating a powerful magnetic field that surrounds our planet like an invisible shield. Earth's magnetic field, or magnetosphere, deflects the most harmful particles of the solar wind, protecting our atmosphere from being stripped away and shielding us from dangerous cosmic radiation. Mars, as we'll see, lost its global magnetic field billions of years ago, and its atmosphere has been thinning out ever since. Our magnetic field is one of our planet's unsung heroes. Now, we can't talk about Earth without talking about its constant companion, our celestial next-door neighbor, the Moon. The first thing to appreciate about our Moon is its size. The Moon is surprisingly large for a moon relative to its planet. It's over a quarter the diameter of Earth. This makes the Earth-Moon system almost like a double planet system. No other planet has a moon that is so significant in proportion to itself, except for Pluto and its moon Charon, which we'll get to. And the story of how we got this giant moon is a violent and dramatic one. For a long time it was a mystery, but the leading theory today is called the giant impact hypothesis. The idea is that the Moon formed about 4.5 billion years ago when a Mars-sized protoplanet, nicknamed Theia, slammed into the very young Earth. The collision was cataclysmic, shattering Theia and blasting a huge amount of Earth's molten mantle out into orbit. This ring of debris then coalesced over time to form the Moon. It's an incredible story. Our calm, steady companion in the night sky was born from the most violent collision in Earth's history. When you look up at the Moon, you might notice that you always see the same face, the same pattern of craters and dark seas. This isn't a coincidence. The Moon is in synchronous rotation with Earth, meaning it rotates on its axis in exactly the same amount of time it takes to orbit our planet. This synchronous rotation is why we have the term the dark side of the Moon. But that name is a bit misleading. The dark side of the Moon isn't actually dark. A better name is the far side. It gets just as much sunlight as the near side does. We just never see it from Earth because it's always facing away from us. It remained completely unseen by human eyes until 1959, when the Soviet Luna 3 spacecraft flew around the back and took the first pictures. The far side looks quite different from the near side, with far fewer of the large dark seas, which are actually ancient volcanic plains, and many more craters. Our moon has a profound effect on our planet. Its gravity is the main driver of our ocean tides. The moon's gravity pulls on Earth's oceans, creating bulges that result in high and low tides. But this process has a slow, long-term consequence. Due to tidal friction, the moon is very slowly drifting away from Earth at a rate of about 3.8 centimeters per year, roughly the same speed at which your fingernails grow. It was much closer in the distant past and will be much farther away in the distant future. This interaction is also causing the Earth's rotation to slow down, making our days very gradually longer. Alright, our brief stop at home base is over. It's time to venture outwards again, to the last of the rocky inner worlds, a planet that has captivated human imagination for centuries. We're heading for the red planet, Mars. Mars is the fourth planet from the Sun, and it's a cold, dusty desert world. The famous red color of Mars comes from the high amount of iron oxide, essentially rust, in its soil and rocks. It's a planet that has literally rusted over. For centuries, Mars has been the subject of our hopes and dreams for finding life elsewhere. And while we haven't found any little green men, we have found something incredibly tantalizing, evidence of a very different past. Today, Mars is cold and dry with a very thin atmosphere, but billions of years ago, it was a much warmer and wetter place. We have overwhelming evidence that liquid water once flowed freely on the Martian surface. Our orbiters have mapped out dried-up river valleys, deltas where rivers flowed into vast lakes, and even what might be the shorelines of ancient oceans. Mars had a thick atmosphere, a protective magnetic field, and liquid water. It had all the necessary ingredients for life as we know it. We don't know if life ever arose there, but finding out is one of the main goals of our exploration of the planet. Although Mars is a much smaller planet than Earth, it's home to some of the most gigantic geological features in the entire solar system. Mars is home to the largest volcano in the solar system, Olympus Mons. This monster is a shield volcano, like the ones in Hawaii, but it's nearly 22 kilometers high, almost 3 times the height of Mount Everest. It's so wide, its base would cover the entire state of Arizona. The reason it got so huge is that Mars doesn't have plate tectonics like Earth does. Here, the crust is constantly moving over volcanic hotspots, creating chains of smaller volcanoes. On Mars, the crust stayed put, and the volcano just kept growing and growing over the same spot for millions of years. As if that weren't enough, Mars also boasts the largest canyon in the entire solar system. Valles Marineris is not a canyon carved by a river like our Grand Canyon. It's a gigantic tectonic crack, a rift valley that formed as the planet's crust stretched and broke apart. It's over 4,000 kilometers long, and in places it's 7 kilometers deep. It's so enormous, it would stretch all the way across the United States from New York to California.
Today, the atmosphere on Mars is very different from its ancient, thicker past. The Martian atmosphere is incredibly thin, less than 1% the density of Earth's. It's mostly carbon dioxide, but because it's so thin, it doesn't create a strong greenhouse effect. This is why the planet is so cold, with an average temperature of about -60 degrees Celsius. This thin atmosphere also means it's not good at blocking radiation from the sun and space, which would be a major challenge for any future human colonists. But even though it's thin, the atmosphere is still active. Mars experiences weather, including clouds, made of both water ice and carbon dioxide ice, and winds. And sometimes these winds can kick up the fine red dust into planet-spanning dust storms. Mars can have the largest dust storms in the solar system, capable of enveloping the entire planet for weeks at a time. Mars also has two very small, very strange moons, named Phobos and Deimos, which mean fear and dread in Greek, fitting companions for a planet named after the god of war. They are not nice, round spheres like our moon. Instead, Phobos and Deimos are small, lumpy, potato-shaped objects that look more like asteroids than traditional moons. And that's probably what they are. The leading theory is that they were once asteroids orbiting in the asteroid belt that were captured by Mars's gravity long ago. Phobos is in a very slow death spiral, orbiting closer and closer to Mars. In about 50 million years, it will either crash into the planet or be torn apart by tidal forces, forming a small, temporary ring. Of course, we know all of this thanks to our robotic ambassadors. Mars is the only planet in the solar system to be inhabited entirely by robots. We've sent dozens of orbiters, landers, and rovers there over the past few decades, from the early Viking landers to modern rovers like Spirit, Opportunity, Curiosity, and Perseverance. These intrepid explorers have been our eyes, ears, and hands on this fascinating world, doing geology, searching for signs of past life, and paving the way for future human exploration. All right, our tour of the inner rocky planets is complete. We've seen the scorched little speedster, a hellish pressure cooker, our own blue oasis, and a rusty desert world. Now we have to make a long journey across a vast, mostly empty stretch of space to get to the outer solar system, where the giants live. And this stretch of space isn't entirely empty. It's home to the asteroid belt. When you think of the asteroid belt, your mind probably jumps to scenes from movies, with spaceships frantically dodging a dense swarm of giant tumbling rocks. The reality is a little different. While there are millions of asteroids in the belt, the asteroid belt is surprisingly, almost unimaginably empty. Space is just that big. If you were to fly a spaceship through the middle of the belt, your chances of accidentally hitting an asteroid would be incredibly small. In fact, every spacecraft we've ever sent to the outer solar system has passed through it without any problems at all. So what are these asteroids? They are essentially the leftover building materials from the formation of the solar system. The asteroids are the rocky rubble that never managed to clump together to form a planet. And the reason for that is the giant neighbor next door, Jupiter. Jupiter's immense gravity constantly stirred up this region, giving the asteroids too much orbital energy. Instead of gently bumping into each other and sticking together, they collided at high speeds and shattered, preventing a planet from ever forming between Mars and Jupiter. The asteroids themselves range in size from tiny pebbles to colossal boulders. But even if you could gather up every single asteroid in the main belt and mash them all together, it wouldn't amount to much. The total mass of all the asteroids in the belt combined is less than that of our own moon, so it's not even close to the mass needed for a proper planet. The largest object in the belt, by far, is a very special one. The asteroid belt is home to a dwarf planet named Ceres.
Ceres is so large and massive that its own gravity has pulled it into a nearly perfect spherical shape. Ceres accounts for about a third of the entire mass of the asteroid belt, all by itself. When it was first discovered in 1801, it was initially classified as a planet, then later as an asteroid. Now, with the official category of dwarf planet, it has a new distinction. NASA's Dawn mission visited Ceres and found a fascinating world, with strange bright spots on its surface that turned out to be deposits of salt, possibly left over from briny water that sublimated from below the surface. It's a very intriguing little world. All right, our journey across the belt is complete, and now we arrive at the court of the king, the undisputed heavyweight champion of our solar system, the fifth planet from the sun, Jupiter. It's hard to convey the sheer scale of this planet. Jupiter is so big that it is more than twice as massive as all the other planets in the solar system combined. You could fit over 1,300 Earths inside it. It's a true giant. Unlike the inner planets, Jupiter is not a ball of rock. It's a gas giant. Jupiter has no solid surface to stand on. It's primarily composed of hydrogen and helium, much like the sun. If you were to try and land on Jupiter, you would just descend through ever denser layers of clouds and atmosphere until you were eventually crushed by the immense pressure. When we look at Jupiter, we see beautiful swirling bands of clouds in shades of white, orange, brown, and red. These bands are streams of gas flowing in opposite directions at different latitudes, creating immense storm systems and turbulence along their boundaries. The most famous of these storms is, of course, the Great Red Spot. The Great Red Spot is a gigantic anticyclonic storm, essentially a hurricane that is wider than the entire planet Earth. And it has been raging for at least 300 years, ever since we've had telescopes powerful enough to see it. It's the most powerful and long-lived storm in the entire solar system. Jupiter's immense size and rapid rotation. Jupiter has the shortest day on any planet, spinning on its axis once every 10 hours, creates another powerful feature, its magnetic field. Deep inside the planet, the immense pressure is thought to squeeze hydrogen gas so hard that it becomes a liquid metal. The rapid spinning of this liquid metallic hydrogen generates the most powerful magnetic field of any planet in the solar system, nearly 20,000 times stronger than Earth's. Its magnetosphere is a colossal structure, a magnetic bubble that stretches for millions of kilometers, trapping charged particles and creating some of the most intense and beautiful auroras you can imagine at its poles. Like the other giant planets, Jupiter has a ring system, but it's very faint and tenuous, made of dust kicked up from its inner moons by micrometeorite impacts. You can't see it with a backyard telescope. It was only discovered in 1979 by the Voyager 1 spacecraft. But perhaps the most fascinating thing about Jupiter isn't the planet itself, but its incredible family of moons. Jupiter's like a mini solar system all on its own. Jupiter has the largest number of moons of any planet, with 95 officially recognized moons as of early 2024, and the number keeps growing as we discover more tiny ones. Most of these are small, captured asteroids, but 4 of them are giants in their own right, worlds that are as fascinating as any planet. These are the Galilean moons, discovered by Galileo Galilei in 1610, a discovery that helped prove that not everything orbited the Earth.
The next moon out is Europa, and it's one of the most exciting places in the search for life beyond Earth. Europa is a world covered in a thick shell of water ice, but the tidal heating from Jupiter
that makes Io so volcanic is also at work on Europa, just more gently. Scientists believe that beneath its icy shell, Europa has a vast global ocean of liquid salt water. And there could be more than twice as much liquid water in Europa's ocean as there is in all of Earth's oceans combined. Where there's liquid water, energy from tidal flexing and chemical nutrients from the rocky seafloor, there is a potential for life. We don't know if anything is swimming in those dark, alien oceans, but it's one of the most compelling places to look. Next in line is Ganymede, and it's a record breaker. Ganymede is the largest moon in the entire solar system, larger than the planet Mercury and the dwarf planet Pluto. It's so big, it's the only moon known to have its own internally generated magnetic field. Like Europa, it's also thought to have a subsurface saltwater ocean, though it's likely buried much deeper beneath a thicker ice shell. Ganymede is a complex world with both old, heavily cratered dark terrain and younger, grooved light terrain, suggesting a dynamic geological history. The final Galilean moon is Callisto. It's the ugly duckling of the group, in a way. It's the least geologically active. Its surface is ancient and absolutely covered in craters. In fact, Callisto is one of the most heavily cratered objects in the solar system, indicating its surface hasn't changed much in billions of years. It's a frozen, preserved record of the early solar system. But even Callisto has its secrets, with evidence suggesting it too might harbor a subsurface ocean. This family of moons is a universe of wonders all by itself. All right, let's leave the majestic king of the planets and its incredible moons behind. Our next stop is perhaps the most beautiful and instantly recognizable planet in the night sky. We're heading for the jewel of the solar system, Saturn. When you think of Saturn, one thing immediately comes to mind: its rings. They are without a doubt the most spectacular and iconic feature of any planet. But first, let's appreciate the planet itself. Saturn is the second largest planet in our solar system, another gas giant made primarily of hydrogen and helium like Jupiter. But it's much less dense. In fact, Saturn holds the title for the least dense planet in the solar system. It is so light for its size that if you could find a bathtub big enough, Saturn would actually float in the water. It's a strange and wonderful thought, a giant planet bobbing in a cosmic tub. But back to those rings. They are breathtakingly beautiful, a shimmering, complex system of icy particles orbiting the planet's equator. For a long time, astronomers thought they were solid disks. We now know they are made up of countless individual particles of ice and rock, ranging in size from tiny dust grains to chunks as large as a house. And while the ring system is incredibly wide, stretching out for hundreds of thousands of kilometers, it is astonishingly, almost unbelievably thin. For most of its expanse, the main rings are only about 10 meters thick. That's about the height of a 2-story house. If you were to scale Saturn down to the size of a dinner plate, its rings would be thousands of times thinner than a single sheet of paper. The ice that makes up the rings is remarkably pure.
the rings are made of about 99.9% water ice, with just a tiny amount of rocky material mixed in. This purity gives them their incredible brightness. It also gives us a clue about their age. For a long time, scientists assumed the rings were ancient, formed at the same time as the planet itself, but their brightness suggests otherwise. Over billions of years, they should have been darkened by dust and micrometeoroid impacts. Their pristine condition suggests the rings are actually quite young, perhaps only 100 million years old. They might be the shattered remains of a small icy moon that wandered too close to Saturn and was torn apart by its gravity.
The structure of the rings is also incredibly complex, with thousands of individual ringlets and gaps. Some of this structure is maintained by the gravitational influence of Saturn's many moons. Tiny shepherd moons orbit near the edges of some rings, and their gravity helps to keep the ring particles in line, creating sharp, well-defined edges. The gaps, like the famous Cassini division, are cleared out by the orbital resonance of larger moons farther out. It's a delicate gravitational dance that sculpts these beautiful structures. Now, looking at the planet itself, Saturn has its own share of wonders. Like Jupiter, it has fast winds and stormy weather, though its colors are much more muted, giving it a pale, buttery yellow appearance. But one of its storms is perhaps the weirdest in the entire solar system. At Saturn's North Pole, there is a gigantic, persistent, six-sided storm system known as the hexagon. Each side of this bizarre hexagonal jet stream is wider than the Earth. It's a stable weather pattern that has been observed for decades, and scientists are still working on models to explain exactly why a storm would naturally form this incredibly geometric shape. And just like Jupiter, Saturn is the host of a huge and fascinating collection of moons. For a long time, Saturn held the title for the most moons. And as of my last update, it has reclaimed that title. With recent discoveries, Saturn now has 146 officially recognized moons, the largest family of any planet. Most are small, icy bodies, but a couple of them are true standouts. The largest is Titan, and it is an extraordinary world. Titan is the second largest moon in the solar system, even bigger than the planet Mercury. What makes Titan truly unique is that it's the only moon in our solar system with a thick, substantial atmosphere. Its atmosphere is even denser than Earth's, and it's mostly nitrogen, just like ours. Walking on Titan would, in some ways, feel more familiar than walking on any other world. But that's where the familiarity ends. The atmosphere on Titan is thick with a smog-like haze of organic molecules, and it is incredibly cold, about minus 180 degrees Celsius. In this deep freeze, a different substance plays the role that water plays here on Earth: methane. On Titan, there is a full methane cycle, just like our water cycle. It rains liquid methane from the sky, which carves out river channels and pools into vast lakes and seas. The Huygens probe, which landed on Titan in 2005, sent back incredible images of a shoreline with smooth, water-worn stones, likely made of water ice, which is as hard as rock at those temperatures, in a dry riverbed. Titan has rivers, lakes, and seas of liquid methane and ethane, making it the only other body in the solar system besides Earth with stable liquid on its surface.
Then there is Saturn's other superstar moon, the much smaller but no less dramatic Enceladus. Enceladus is a small, bright white, icy moon. For a long time, it didn't seem particularly special, but then the Cassini spacecraft flew by and saw something astonishing. Erupting from long cracks, or tiger stripes, at the moon's south pole were gigantic geysers of water vapor and ice particles, spraying hundreds of kilometers out into space. This was a bombshell discovery. This little moon was geologically active. The geysers are evidence that there is a global ocean of liquid salt water beneath Enceladus's icy shell, just like on Jupiter's moon Europa. These geysers of water ice are so powerful, in fact, that they are the source of Saturn's faint E-ring. Saturn has a ring made by one of its own moons. Even more excitingly, when Cassini flew through these plumes, its instruments detected not just water, but also salts, silica dust, and complex organic molecules, all the key ingredients for life.
Uranus also has a ring system. Although it's much fainter and darker than Saturn's, the particles in its rings are very dark, almost like charcoal, making them very difficult to see. It also has a family of moons, with 27 known so far. In a break from the tradition of naming moons after figures from classical mythology, the moons of Uranus are named after characters from the works of William Shakespeare and Alexander Pope, with names like Titania, Oberon, Puck, and Miranda. The planet's magnetic field is also incredibly weird. It is not generated from the planet's geometric center, and it is tilted by nearly 60 degrees with respect to its rotational axis. The result is a messy, wobbly magnetic field that is far off center, which creates some very strange and complex auroral patterns. Uranus holds the record for the coldest planetary atmosphere in the solar system, with temperatures dipping down to a frigid -224 degrees Celsius. It's actually colder than Neptune, which is much farther away from the Sun. Scientists aren't entirely sure why, but it may be related to its strange tilt and how it affects its atmospheric dynamics. It's a cold, tilted, and deeply mysterious world. Now, let's make the last great leap of our planetary tour, journeying to the 8th and final planet in our solar system. We're heading for the deep blue, windy world of Neptune. Neptune is the other ice giant, very similar in size and composition to Uranus. And like Uranus, its beautiful, vibrant blue color comes from methane in its atmosphere. But where Uranus often looks serene and placid, Neptune is a much stormier place. When Voyager 2 flew by Neptune in 1989, it discovered a huge, dark, swirling storm system that was nicknamed the Great Dark Spot, reminiscent of Jupiter's Great Red Spot. It was a massive anticyclone about the size of the Earth with ferocious winds. But when the Hubble Space Telescope looked at Neptune just a few years later, the spot was gone. It had completely vanished. Since then, other dark spots have appeared and disappeared on the planet.
Triton is also one of the coldest objects in the solar system, with surface temperatures around -235 degrees Celsius. But despite this deep freeze, it is geologically active. When Voyager 2 flew by, it saw dark plumes rising from the surface. These are cryovolcanoes or ice volcanoes. They don't erupt molten rock, but rather a mixture of liquid nitrogen, methane, and dust from beneath the surface, which then freezes and falls back down as a dark snow. It's a wild, icy, and backward world. And with that, our tour of the 8 official planets is complete. But our journey isn't over. We are now heading into the vast, mysterious third zone of the solar system, a region of icy bodies and dwarf planets known as the Kuiper Belt. This is the frontier, the realm beyond the giants. The Kuiper Belt is a donut-shaped ring of icy objects extending from just beyond the orbit of Neptune. It's similar to the asteroid belt, but it's far larger, about 20 times as wide and 20 to 200 times as massive. It is populated by hundreds of thousands of icy bodies larger than 100 kilometers across, and an estimated trillion or more comets. The most famous resident of the Kuiper Belt is, of course, Pluto. For 76 years, from its discovery in 1930 until 2006, Pluto was considered the 9th planet. But as we started discovering more and more objects in the Kuiper Belt that were similar in size to Pluto, astronomers had to make a decision. They created the official category of dwarf planet, an object that orbits the Sun and is large enough to be spherical, but has not cleared its neighborhood of other objects. Pluto was reclassified, becoming the first and most famous dwarf planet. For decades, Pluto was just a faint, blurry point of light in our most powerful telescopes. But that all changed in 2015 when NASA's New Horizons spacecraft performed a spectacular flyby. It revealed a world of stunning complexity and beauty.
So, as you settle in and get ready to drift off, maybe just hold on to a little bit of that sense of cosmic perspective. Our world, with all its worries and wonders, is just one small, beautiful part of a much larger, much more complex family. We are living on a pale blue dot, a precious haven, orbiting a fairly average star in a quiet suburb of a vast galaxy. And our neighborhood is filled with the most incredible, fascinating, and sometimes just plain weird neighbors. It's a reminder that the universe is not just empty space, but a place of immense variety and endless possibility. It's a story of fire and ice, of cataclysmic collisions and slow, patient orbits, of deep mysteries and stunning discoveries. And it's our story, because we are a product of this system, made from the dust of long-dead stars, living on a world shaped by its gravitational dance. So, let your mind drift. Think of the silent, swirling storms of Jupiter, the elegant, icy rings of Saturn, or the lonely, distant light of the Sun warming a mountain of ice on Pluto. There is a deep and quiet beauty in it all. Sweet dreams, and may your journey through the cosmos be a peaceful one.